this is basic education for South Africa. This is the first video that we do on this. So it's very similar to ZIMSEC videos. If you're doing ZIMSEC or if you're doing Cambridge, then this is a very good starting point for you, especially for paper 2. Okay, so we're going to do one question at a time. They're very long, these papers, but then they're very informative. I went through the whole paper, and then this is the 2017 one, I think November. So it was really good and it was really informative. There's an overlap, so you learn so much from it. The question 1, it says you're given this expression. Okay, so Q equal to square root of b squared minus 4ac. This is actually called the determinant. So b squared minus 4ac, it's actually called the determinant, but here we're just given as an expression. We're just supposed to understand it as it is. Okay, so question 1.1.1 says determine the value of Q if, so this is a matter of substitution. Okay, and you're asked to leave your answer in the simplest surd form. Okay, you're asked to leave it in the simplest surd form. Okay, so Q equal to then square root of, if you're substituting, I always encourage you to use brackets. Every time, just use brackets, because sometimes you get the negative signs messed up there. So here -4, our A is what? Our A is 2, and then our C is what? Our C is -4. Okay, so you take things in steps, and then here square root of, then -1 squared. Here any negative, when you square it or when you power it to an even power, the negative disappears, it becomes positive. Okay, so you're actually looking at 1 there. And here you have negative, then negative here, so negative and negative, you get positive. Same signs always yield positive when you're multiplying. So, and then you have 4 by 2, that's 8, then 8 by 4, so 8 by 4 you get 32. Okay, another way to do it was I could have said 4 by 4, then you get 16, then by 2 you get 32. So 32 here, and then square root of, well, here you simply add because they are under the same square root sign. Okay, so you actually get square root of 33 here. So this would be your answer. So what you did is, whenever you're substituting, every time you're substituting, substitute using brackets for each and every variable that you're substituting there. Okay, then you simplify in steps, just like this. You take the square root on the last step. Okay, so for example here, we don't take the square root as of yet. We actually have to add 1 plus 32. Then we get 33. Then we stop there. Okay. So you're asked to state whether Q is rational or irrational. Okay, so 1.1.2. So Q is irrational, and then I'll explain to you what that means. So any number that you cannot express in this form, A over B, where A and B are elements of integers. Okay, so anything that you can express in fraction form where there is numbers, it's a rational number. So for example 17 over 13, this is a rational number. It's a reasonable number. It's a number that you can express in terms of natural numbers like this. Okay, even sometimes they trick you. It can be 1.7 over 1.3. This is simply 17 over 13 as well. As long as you can express it in terms of a numerator that's a number and a denominator that's a number somehow, then that means that that number is a rational number. If you can't do that, then that number is an irrational number. Okay, so Q here we cannot do that. Square root of 33 simply means square root of 33 over 1, of which here we cannot express this in terms of a natural number, in terms of an integer. So that's where the problem is, and that's why we conclude that Q is irrational. So you just note right now what's the difference between rational and irrational numbers. Okay, and then 1.1.3 here, You're asked between which two consecutive integers does Q lie. Okay, so Q lies between which two consecutive integers. So you can do this by a process called inspection. So you can inspect your number and expect, okay, what would be the lower bound, what would be the earlier square here. The earlier square would obviously be what? Be 25. Okay, and the later square after 33 would be 36. Okay, so 33 lies between these squares. Okay, so 33, it's less than 36, it's also less than this. So when you're taking the square root of this, it's here I say 25, sorry, I don't know why I wrote 27 there, so it's kind of late here, so mistakes. But then here essentially you get square root of 33, then square root of 36 here you get 6, then square root of 25 here you get 5. So obviously this is how you'd show working, by the way. So you're inspecting 33, you're saying, okay, which nearest number when we're going down do you find a square? So it's obviously 25. After 25 you'd get 36. So 33 is kind of sandwiched in between. So then you take square roots of all the numbers, then you realize it's between 5 and 6. So which two consecutive numbers does Q lie? So you're saying, say Q lies between 5 and 6. Okay, so this is it. And here you're asked to leave your answer in simplest set form. So I didn't tell you about this. So essentially set form is this form. So a square root of b. Okay, so if these components don't have, so for example square root of 33, it doesn't have any square inside of it in terms of a multiplier, so that's why we just leave it at square root of 33. But then if it were, say, square root of 72, I'm just telling you in passing, but what I'll do is I'll actually do a dedicated video on this. You'd actually realize that this is square root of 2 by 36. Okay, this is equal to square root of 2 by square root of 36, of which square root of 36 we know it's 6 square root of 2. This would be the simplest set form for square root of 72. Okay, so but then it was unnecessary, it was redundant for our case, because we had square root of 33, which we say 33, I'll also make another video to tell you why we cannot break down 33 in the form that we talked about. But for now, let's move over to the next question. So the next question says, factorize the following expressions fully. Okay, so factorize the following expressions fully. So you have this. So let me copy it. It's t squared r minus s minus r plus s. Somehow this by inspection you can see that r minus s and negative r plus s, they're kind of familiar. They actually, the other one is negative of the other one. Okay, they're a negative of the other. So here, this one, you can actually match these brackets here. So let me show you what I'm talking about. So you get r minus s. If you factor out negative here, you get r, then negative and positive, you get negative s. So you've matched these brackets. Okay, so if you have matched these brackets, you're allowed some negative, then you just have brackets straight on. It simply means that there was a 1 here. That's what it simply means. So if you don't put any number, that the coefficient for that, or the number, the multiplier for that bracket, it's simply 1. Okay, so here what you do is you can I'll show you the direct way to do it, and then I'll show you why you can. Okay, let me show you the round way to do it, and then I'll show you the direct way to do it. Okay, so here r minus s, it's common, so you can actually factor out r minus s here. Then you say r minus s into this. This is a whole term. Okay, this multiplying this, it's a whole term, so it actually get t squared here. Then minus here would be 1. Okay, so this is how you go about it. Or you can just simply take this and take this, and then they make their own brackets, and take this and then they make their own brackets. we are not done yet. This one you're supposed to recognize it. It's a difference of two squares. So you have a square here, t squared, so it's a square. So t is the square root, and then minus 1 is also a square, 1 is the square root. Okay, so you can actually further factorize this such that it's r minus s. Then we'd have t here, which is the square root, and t here, which is the square root for t squared here. So you put your square root, you put your square root here. Then 1, the square root is what? It's 1 as well. So you get plus 1 and you get minus 1 like this. So this would be your final answer. Okay, so here you had 3 marks, so you'd get 2 marks if you do it up to this point here. Okay, but you're supposed to further break down t squared minus 1 by difference of two squares. You recognize it by there will be a negative here, and then there was also be a square here, a square here. Okay, so this is it. So let's move on to question 1.2. Okay, so you asked you factorize this. So x cubed plus 1 divided by x squared minus x plus 1. So your first takeaway here is that normally we would have to factorize these individually, but then this bottom factor here, so this bottom term here, it actually doesn't have any factors. Okay, so in other words, you cannot factorize x squared minus x plus 1 like this. You cannot factorize it. It doesn't have any terms that satisfy this condition here, where it's x something plus, let's say, a, then plus b. Okay, so that's a problem. So what you do is normally when they give you this, the implication would be that this one, it's a square of, it's a factor of this one here. So you actually have to figure out like what's the other square here. So you have you can put this aside, and then you have x cubed plus 1 equal to, let's say it's equal to x squared minus x plus 1 here. But then you don't know what the other factor would be, so you can say plus, let's say, a, and then you now have to determine the value of a. Okay, so you have this, you're guessing that it's a factor, and then you want to check what value of a would satisfy that. So you get x cubed plus 1 equal to, then you get here, when you expand, you get x cubed, then on the x squared part you get a minus 1. So I'm doing it by inspection, so I'm inspecting here x squared times a, then you get a x squared, so a here, then x multiplied by x, so obviously you get x squared as well here, so you'd get this, and then on the you'd get this one will be squared because we're dealing with squares, right? We're dealing with the squared part, so this one and this one and this one and this one. Now we're going to move to the x part. So x part would be this one negative a, so in the sense of negative x plus this, so you get negative a, so you can even say plus here. So after saying plus, you get negative a here, then here you get x, so negative a plus 1 x here, and then on the numbers you just get a. Okay, so now you are going to investigate if a is consistent. So if this would make sense if the value of a is consistent. So here the last digit, the coefficient of x to the power 0. So the last digit here, which is the coefficient of x to the power 0, it's what? It's 1. Okay, so you say by inspecting coefficient of x to the power 0, we have a equal to 1. Okay, so when you put 1 here, you're actually, this x squared factor disappears. So let me show you. So you have x cubed plus a minus 1. So you want to check if it's consistent. Then plus negative a plus 1, then plus a like this. So here you would be substituting a. So here you get x cubed, then 1 minus 1, you get 0. So plus 0x squared Then here you also get 0 again, so it was minus 1 plus 1, you get 0. So plus 0x, then plus 1, you'd get x cubed plus 1 like this. So here, what I'm noticing is that they only give you 2 marks. So in actual fact, they expect you to know that if you factorize this, you get x squared minus x plus 1 and the other factor, which is what we found here. So it was x plus 1, okay, x plus 1. Then you divide this by x squared minus x plus 1 like this. So you have to cancel the commonalities. So this one cancels this one, and then you're left with x plus 1. Okay, so the ZIMSEC people, you might not get specifically this type of this question as it is right now, because you are not expected to be able to factorize trinomials. But then normally what happens is you actually use the same concept where you have to factorize. When you factorize, you expose the factors, and thereby you can actually cancel them as they are right now. As it stands in this format, you could not tell whether this was a factor or not. That's why I actually had to go through all this hassle in order for me to sustain that this was a factor somehow. But then the way that I'm seeing it, if they give you 2 marks here, they expect you to know that from now on, know that x cubed plus 1 is equal to x plus 1. Then we'd have x squared minus x plus 1 like this. Know this. Okay, then you recall it in your formula. So for the South African students, and then also you should also know the one for x cubed minus 1. Okay, so look this up and then also know how it's factorized. Those two we expected to know. Okay, but then essentially this is what we get, x plus 1, and then the other one we computed already. So let's move over to the last question for this first part here. So simplify the following completely. We're doing factorization. This needs expansion. Okay, so we are now doing the reverse process. So we have 7y squared minus 6y minus 8 like this. So here what you do is each individual, since you just have 2 brackets, you can multiply first by the first entry. Okay, so they're taking tens to multiply the same thing. So this was actually minus 6y minus 8 here. Then you have 3, so plus 3, 7y squared minus 6y minus 8 like this. Okay, now you now expand. So 2y times 7y squared, so you get 2 by 7, you get 14 y cubed. Okay, so and then for this part it would be negative 12. So 2 times negative 6, you get negative 12 y what squared. Then for this part you'd get negative 16 y. Okay, and then for this part you'd get 21 y squared. Okay, and then for this part you'd get negative 18 y. So 3 multiplied by negative 6, you get negative 18, and there was a y already, so you get this. And then 3 multiplied by negative 8, you get negative 24. We only have one entry for y cubed, so we'd get 14 y cubed simply. But then here you have 2 entries for y squared, so you get negative 12 plus 21. So you get what? You get 9. Okay, you get plus 9 here, 9y squared. Okay, so negative 12 plus 21, you get plus 9. Okay, it's like 21 minus 12, you get 9. Okay, then negative 16, negative 18, what do you get? You simply get negative, so negative and negative 16. If you're doing negative 16 minus 18 here, it simply means you take answer takes negative, which is you're putting sign here, and then you simply add. So 16 plus 18, it's what? It's 34, I think. Yeah, it's 34. So it's negative 34 y. Okay, then you have negative 24 as it stands on its own. Done. Okay, so what we did is we expanded this bracket here. You first take the first entry and then you multiply, and then the other entry also takes its own 10 and then it multiplies again. Then you collect the like terms. Like terms for a case there, this one it just has one entry, but then these ones you actually had to simplify, and then these ones you actually had to simplify, and then you get this. So let's move to question 1.3.2. So question 1.3.2, we need to use the space. So you have 1 over, this one you can actually factorize. This is difference of two squares. So it's simply x plus 3, x minus 3. How do I know that this is difference of two squares? Because x squared is a square, and then 9 it's also a square. Okay. Then this one is already factorized for you, and you don't have to expand it. Okay. If you expand it, you're actually doing something, you're actually risking something there. So here you're supposed to take the lowest common multiple as your common denominator. Okay, so for this x minus 3 squared, you take x minus 3 and x minus 3 squared. X minus 3 is common. Okay, and for lowest common multiple, when you have common entries, you take the one with the greater power. So you'd have to take x minus 3 squared like this. And then x plus 3 is just standalone, so it's x plus 3 like this. Okay, so this one into this one, you get you get x minus 3 here, which would be left out when you cancel one of the x minus 3 here. Okay, so you get x minus 3 like this. So x minus 3, it will cancel one of the x minus 3 here, and then x plus 3, it will cancel this one. Okay, so and then this one into this one, it cancels, and then you're simply left with x plus 3. So after this, what do? You simply expand. So this would be a 3x minus 9 plus 2x plus 6 like this, divided by then x minus 3 squared x plus 3 like this. So here you get 5x. So as in 3x plus 2x, you get 5x, then 5x minus 3. Okay, since you have negative 9 plus 6, you get negative 3. So over x minus 3 squared x plus 3. Done. So this is it, you're done. Okay, so this one, what we did was we recognized difference of two squares, and then we put the common denominator here. The common denominator would be the LCM. Okay, if this confused you, you have to do LCM of algebraic functions. Algebraic functions, okay. So LCM of algebraic functions, we applied that principle here. We also try to do a video on that. And after doing LCM of algebraic functions, we then expanded. So we then expanded this part, expanded this part, and then we grouped the entries together. So this one and this one, they are like terms. So we simply say 3x plus 2x, then you get 5x, then minus 9 plus 6, then you get negative 3, and then that's it. This one you cannot further factorize it, so there's no need for you to tinker with it. It will just live up to this part. Okay, this was an interesting paper actually. South African papers, they're interesting. So now we have 1.3.3. You have 3 to the power t minus 3 to the power t minus 2 like this, and then divided by 2. 3 to the power t, this is an interesting question, minus 3 to the power t like this. Okay, so what do? Here what you can do is you can say 3 to the power t. You want to, if they are subtracting, it means that they can only subtract if they are like terms. Okay, so you actually have here would be 3 to the power t multiplied by 3 to the power negative 2 like this. You're just doing the reverse of what the laws of indices tell you. Okay, so normally if you had 3 to the power t multiplied by 3 to the power negative 2, you'd have 3 to the power t minus negative 2. And so we just did the reverse there. And here 3 to the power 2 to the power 2 by 3 to the power t minus 3 to the power t. It simply means you have two 3 to the power t's. Okay, so these entries, you have two of them, and then you're asked to subtract 1 3 to the power t. Obviously you'd get 3 to the power t here, or 1 3 to the power t. Let me illustrate. Okay, so you can have, let's say, 2x minus x. 2x minus x is simply equal to x. 3 to the power t is an entry, just like x, so it can be y or something like that. So you can have, well, what it simply means here is you have 2 3 to the power t, you have 3 to the power t, and you have another 3 to the power t. Now you're subtracting 1 3 to the power t. So obviously you'd get 3 to the power t just like this. Okay, so that's what happened. And here, so you can actually factor out 3 to the power t because it's common on the denominator, at the numerator. So you'd have 1 here minus 3 to the power negative 2, like this. Then divided by 3 to the power t. So here you'd have to cancel stuff. So this one and this one, they cancel out. And once they cancel out, now you're left with 1 minus 3 to the power negative 2. So 1 minus 3 to the power negative 2, you flip this one. And then this power becomes positive. So 3 power 2. So you have 1 minus 1 by 9. And which is equal to what? 1 minus 1 by 9, you get what? You get 8 by 9. And then this is it. Okay. So these are very interesting questions. I didn't know that South African questions are this interesting. So this was it for the first question, so question 1. And when we're back, we'll be back with question 2. So this is basic education for South Africa. This is grade 10, the November 2017 paper, I'm sure. So thanks for watching. Make sure you like, share, and subscribe. Cheers.